Okay, so we're going to take a brief foray backwards and talk about how trig functions are odd and even, and actually which ones. In fact, all 6 are. It's actually a pretty simple process because we only need to look at 2 to figure it out. Here's why. So which ones? So let's take a look at sine. So remember, well, let's take a look at cosine first, actually. So when we're looking at this, it means that we need to have some angles in mind because remember when we're talking about even, right, that means that f of t equals f of opposite t, right? So that's even, believe it or not. And then odd is when f of opposite t equals opposite f of t. Now, it turns out if you can remember 2 of these functions, then the rest kind of builds logically from it. I'll show you why here in a sec. So let's talk about cosine. So if we're talking about cosine, we have to compare cosine of, we'll say, t, and we're going to have to compare cosine of opposite t and see how they compare, right? So we'll start there. So the cosine of t would be the x-coordinate right here at, let's say, some positive angle t. And that would be the cosine, right, of t would be right there. And then we have the sine of t here, yes? Opposite t would be down here, okay? Meaning, if you think about this, like if this was 45 degrees, this would be negative 45 degrees. It would mean that the cosine of t would be the same. Because if you look at this, because this is a coordinate plane, positive x, but the sine would be the opposite. So in other words, this would have the same magnitude, the same value, but this would be positive, this would be negative. So what does this mean? Well, oddly enough, well, okay, we started with cosine. Evenly enough, it means that the cosine of t is equal to the cosine of opposite t, which means that cosine is an even function, okay? Now, it turns out that, because of what I just talked about, if you look at sine, the sine of t, so it turns out that the sine of t is going to be some value, but then the sine of opposite t is going to be the opposite. So if I'm looking at the sine of opposite t, it is equal to opposite sine t. And there it is right there. The sine of that angle is equal to the opposite of the original, okay? What does that mean? It is an odd function. Are you ready for alphabetics? Cosine becomes before sine alphabetically. Even comes before odd alphabetically. That may help, okay? Now, here's how you can get the rest of them. So the rest of them include secant, cosecant, tangent, and cotangent. Now remember, secant is 1 over cosine. Cosecant is 1 over sine. Tangent is sine over cosine. And cotangent is cosine over sine. So here's the argument. You ready? Only one of these other functions is actually even, and that is secant, which is wholly based upon cosine, right? Because if you plugged in, no matter what value you plugged in, it's going to be bulletproof. It's going to give you the same sign back either way. However, when you do sine, it's going to change. Now this has a cosine which won't change, but if one changes, it means it changes sign. So it turns out that all the rest of these things are indeed odd because they are based on sine, which is an odd function. So what does this mean? It means in sum that we have some even trig functions and some odd trig functions and some very useful little things we get from the fact that they're odd and even. The even ones are cosine, and the cosine of t equals cosine of opposite t, meaning no matter what the angle is, as long as it's the same magnitude, positive or negative, doesn't make a difference. We also note the secant, and the secant is the other even function, because it's based off of cosine, right? Is secant t is equal to secant opposite t, versus odd is sine, where the sine of opposite t is equal to opposite sine t, and likewise with its reciprocal identity, cosecant. and tangent, which is based off of sine. So the tangent of opposite t is equal to opposite of the tangent of t, and cotangent. Okay, how could this be useful? Whoops. Let's erase that. Well, here's how this could be useful. What if someone, like me, said that the cosine of theta was equal to 5, right? I'm sorry, that's never going to be possible. Cosine can never be more than 1, is equal to 0.5 there. What does that mean that the cosine of opposite theta is? It's also negative 0.5, right? Or what if someone said that we're looking at the sine of 60 degrees, right? What would the sine of negative 60 degrees be? It would be the opposite of that, right? So sometimes that can save you a bit of grief. Sometimes you can calculate it directly. But these are the even and odd. Now these are considered to be identities because they're true for any value of t with respect to sine, cosine, and tangent. Remember, cosine even, even cosine, first alphabetically. Sine odd. And anything based on just cosine is also even. Anything based on sine has to be odd. All right? And that's actually about it.